A pellet of mass m traveling at speed u hits a stationary block of mass m. So this question is about a small mass hitting the big block here. So this question is about the momentum. So the pellet becomes embedded in the block and it causes the block to move at the speed v immediately after the impact. So from this first part of the question, you can form an equation about the momentum. So let's look at what we have here. Small mass m, the big mass m as well. So the small mass m move with the initial speed u, and then they both move with the v after the impact. So let's look at here. You have u here. So before the collision. So let's form before the collision. So before collisions, you have mu plus m times. So this is not moving because of the stationary. When you see the term stationary, this should be 0 meter per second. So times 0. So the momentum before the collisions should be equal to mu only. So after the collision, so you will know that this small pellet is embedded into this one. And then if you realize the last part of this question, so we will neglect the small increase in the mass of the block as your pellet added. So after the collisions, your total mass, so by right, the total mass should be m plus m, but we say the question say that this should be negligible, so you ignore this one. So total mass will be equal to the capital M only. So after the collisions, it should be mv. So by the principle of conservation of momentum, so the momentum before and after should be equal. Okay, so you have mu equal to mv. So we can form one equation for v first, mu over capital M. This is your first equation from the first situation here. All right, the next one, look at the next situation. So now the pellet has a mass of 2m and now travel with a speed of 2u, hitting a mass of 2m. So what is the speed after the block, after the impact? So for the second situation here, so let us see what can we do for this equation. So before the collision, you have the same things, 2m as the mass now, and then the 2u plus the mass of 2m times 0. So the momentum before the collisions should be equal to 4mu. For after collision, so we ignore the mass of the pellet as well. So you have 2m times, let this speed to be v2. So you have 2m v2 equal to 4. Okay, we just let it to be 2 mv2 first, have the final momentum. So before the collisions and after the collisions, their momentum should be the same. So 4mu equal to 2m v square, sorry, v2. So v2 equal to 2mu over m. So this is the second equation. So if we look at equation from the first collisions. So V, you have mu over m from the first part of your equation. So your final speed for the second situation will be 2 mu over m, so will be 2v. So this will be the correct answer here. So it will be 2v. So answer will be C.